Okay, this last section talks about problem solving, and Poya's problem solving steps are pretty famous, I guess, in the math world. And so, what they are is, first of all, you need to understand the problem. If you read it and you don't even know what it's asking for, it's kind of hard to figure out the problem. So, first of all, just read it enough times so you actually understand what you're trying to figure out. And then after that, obviously, you're going to devise a plan. So you're going to try something, all right? So you're going to think of, okay, what should I do? And then you're going to actually do it. So you're going to carry out the plan. Okay, and then after you carry it out, you're going to look at your answer and see if it even makes sense, and then you're going to look back. And sometimes you have to do this process over and over and over again, because when you look back, you realize, oh yeah, that doesn't make sense. And so then you're going to have to read it again, make sure you understand it, devise a different plan, and go so forth. So problem solving is messy. It's not a fast process. So most of you, when you think of math, you're like, oh, if I can't solve it within a few minutes, I don't get it, or I'm dumb, or whatever. And that's not really real math. In real math, some people spend years, aren't a problem. And then sometimes after years of work, they realize that they were wrong and they have to look at it from a different direction. So math, as far as like what a mathematician would do, is very slow and not very fast at all. All right, let me change colors here. All right, so some strategies. So if you're solving a problem and you're trying to think, how to do this, and we're just talking about general problem solving, so not necessarily in an algebra course, just trying to think about, how to solve a problem that you've never seen before. One thing you could do is maybe draw a picture. Sometimes it helps you like to see, kind of what it looks like. And again, your picture doesn't have to be pretty or accurate as far as exactly, exactly what is going on, but it could be like if you're talking about two people, you might use dots to represent the two people, or if you have three people, and then you might do something with that. Another strategy is guess and test. And usually at the elementary level, kids love this method, but then when they get into high school and college, they're like, that's kind of like a baby method. Not necessarily. Sometimes guess and test can be pretty fast. I used it quite a bit when I took the GRE to get into grad school, because it was faster to guess and test my answer than it was to do algebra. Sometimes a table, like organizing it in a table, you can kind of figure a pattern or something like that. So again, looking for patterns. Sometimes you can model it either with manipulatives or drawing. You maybe could model it with algebra. And again, that kind of goes with patterns too. Maybe there's a pattern that is algebraic. Sometimes you can work backwards. So instead of trying to think of how to do it in a forward direction, maybe start at the end and work backwards. And sometimes maybe an easier problem. So if you're stuck, you're like, all right, I have no idea. So instead of like, say there's a problem with like, I don't know, maybe a bunch of people, and you're like, oh my gosh, there's too many people, I don't know what to do. Maybe try that same problem with maybe just 3 people and kind of see what happens when 3 people. Then maybe try it with 4 people, and then maybe with 5 people, and so forth. So these are just a few strategies for problem solving. There is many more, I'm sure, but the main idea is try something, all right? So just try it, and if it's wrong, okay, well then look back and try to be like, okay, what could I do differently? But the main thing is you have to be a risk taker, and you have to try to do something.